Hi everybody, so in this video we're going to do some practice with utility. Now this first one is just explain this to someone else using the idea of marginal utility. And the idea is newspaper vending machines are designed so once you've paid for one paper, you basically can actually take more than one paper at once. If you've never used one before, you put your coins in, open it up, and then the whole thing is there. But soda vending machines, once you pay for one soda, they dispense only one soda. And that's the idea behind that, like, you get marginal utility out of a second soda, but you don't get any marginal utility out of a second newspaper because they're all identical. And so there's no additional benefit to having them. So the second one, it says, given the table and a consumer income of $7, identify the combination that maximizes utility. Now remember, we're looking for where mu over p is equal to mu over p. So we're going to need to do some columns here. We need especially the mu column and the mu over p column especially. So I've tried to leave you some space here. Now let's go ahead and write mu over p here, and mu, and then I'm actually going to put mu over p separately on this one. And then it'll make sense in a second why. So for the first one, what's the marginal utility as you gain the first apple? Well, the marginal utility is the change, so it's 0 to 20, and that's just 20. Now the price, divided by the price, is $1 for each one of these. So that's why I didn't create a second column, because they're all going to be the same. So it's just 20. And then 1 to 2, you go from 20 to 35, and so that's 15 divided by 1 is 15. 35 to 45 is 10 divided by 1 is 10. 45 to 50 divided by 1 is 5 divided by 1, which is 5, and then 2. Now we're going to fill out this column, and I'm going to do the marginal utilities, and then I'll do the marginal utility per dollar. So the marginal utility is the change, so that's 30, 20, 15, 10, and 5. And now per dollar that you spent is the oranges are $2 a piece. And so we're going to take this mu and divide it by 2. 15, 10, 7.5, 5, and 2.5. Now, this is usually where students make mistakes. So be careful when you're dividing here. You're just dividing by that price of the orange, of that, second, third, fourth, fifth, sixth orange. You're just dividing by that one unit, the last unit's marginal utility divided by the last unit's price. So now we just take our 2 pointing fingers, right, and we compare, and we say, are there any 20s? No. Okay, so we rule that one out. Are there any 15s? Yes. So we're going to test this combination where it's 15 and 15. And let's see, apples at $2, or apples are $1, so 2 of them would be $2, and 1 orange is $2. And so that's 4, we have 7, so that's not the correct combination. So let's keep moving. We don't have 15, we have 10. 10's another one, so let's test this one where it's 10, and that would be 3 apples. So 2 oranges at $2 a piece is 4. And then we have this one is 3 apples at $1 a piece, that's 3. And so 3 plus 4 is 7, and that's our budget. So the correct answer is 2 oranges and 3 apples. Okay, and so in the explanation, we aren't really asked for that. The explanation can be because mu over p is equal to mu over p, and we can actually just say it's 10 is equal to 10, because that's what those values are. Now, Sophie is a utility maximizing consumer who spends all her income on bananas and peanuts. That's weird, which are both normal, okay. The last unit of peanuts increases her total utility from 40 to 48. The last unit of bananas goes from 52 to 56. So that's telling you the marginal utilities. So let's just say marginal utility of bananas, what was that? 52 to 56, so that's 4. And the marginal utility of peanuts, I'm just going to use N because P is for price, N for nuts would be 8. Okay, and then it says if the price is $1 for peanuts, what's the price of what's the price of bananas? And we know she's utility maximizing, so we know she's doing that, right? She's doing this. And so we would say the marginal utility over price is equal to the marginal utility over price. And so marginal utility of bananas is 4, and we're looking for the price there, but we don't know that. And so then we know that's equal to 8 over the price of peanuts, which is 1. So some value here is going to be and this is $1, and this is some dollar value will give us that equivalency. And hopefully you can spot that the price of bananas is equal to 50 cents. Okay. If the price of peanuts, though, goes up and the price of bananas stayed the same, how will Sophie's purchase of peanuts change? Now, this is a little bit more complex, but it just kind of tests out a thinking process with me, right? Imagine if the price of peanuts went from $1 to $2, okay? And so, we know that we were here, right? Because that's the banana side and that's the peanuts side. And so now we were at this, and now we're going to go to 4 over 0.5 is equal to 8, or it's not equal to 8, right? 8 over 2. So this is 8, and this is 4. So which one's bigger now, right? The bananas or the nuts? Which one has the bigger one? Well, it's the bananas. 8 is bigger than 4. And so how will Sophie's purchase of peanuts change? Remember what I told you in the previous video was you should consume, if they aren't equal, you should consume more of the thing that gives you the larger mu over p. Remember, we've got our little Pac-Man, and he's got teeth, and he wants to eat more of the bananas. So they're going to consume more nanas and less nuts. There's your answer. Hopefully that helps you. I'll see you next time.